In 2019, Nova Scotia Power launched an innovative pilot program called Smart Grid Nova Scotia. The goal of the project was to learn new ways of how electricity could best support the renewable energy transition. It's about how to make the grid smarter and evolve to energy demand, all while being more reliable. Ed Cullinan is the Senior Manager of E-Mobility and Residential Electrification at Nova Scotia Power, and he's here to talk about the Smart Grid project. The project is wrapping up, but Ed is going to tell us what they've learned from this pilot and how it will inform what comes next. Hi, Ed. Welcome to Reimagined Energy.
Hi, thanks for having me.
We met recently at the Smart Energy Conference. It was really great to have a quick conversation there and get to know a little bit about your work at Nova Scotia Power. But I'm always curious, with guests that come on this podcast, why they became interested in energy, and tell everyone a little bit about your energy story.
Yeah, well, it was great to meet you at the event and learning that you were one of our EV Smart Charging customers. So that was fun. But my story began, I started in a traditional sort of utility role at a natural gas utility in Alberta. Worked for ATCO Gas in Calgary for 10 years to start my career in, and sort of had two stories there. Where the first sort of 5-6 years was traditional engineering, construction operations, building gas distribution facilities to new subdivisions and buildings in Calgary. And then got involved in a project called the Drake Landing Solar Community in Okotoks, which is a district heating solar thermal project that's pretty well known around the renewable energy space, and started then from there getting into more new energy concepts, and later in my career with ATCO in corporate innovation and transformation. And so that was sort of the second half that transformed what I wanted to do in energy space or in the utility space. Then during the pandemic, I had an opportunity to come east to Atlantic Canada, where I'm originally from, and work with Nova Scotia Power on specifically Smart Grid Nova Scotia project, and start basically a third chapter in my energy career, working directly with customers on how to make their energy use easier and better, and how they can participate in transformation of the energy system.
Talking about the Smart Grid project and how it began, it was initially, or is it always part of a larger Smart Grid Atlantic initiative, I'm told. So how did it all begin?
Yeah, so Smart Grid Nova Scotia is part of the Smart Grid Atlantic initiative. It was a partnership between NB Power and Siemens Canada to investigate the best way to integrate distributed energy resources into the energy system in Atlantic Canada, leveraging the development and testing of an energy system platform from Siemens, which is software to coordinate all of those resources, whether that's solar, batteries, or EVs, and then share the learnings between the two utilities in NB Power and Nova Scotia Power. And so when we think about Smart Grid Nova Scotia, that was our sort of customer-facing brands in Nova Scotia that encompassed some of the suite of programs that we offered during that pilot project in Nova Scotia.
Can you briefly describe the project and I believe it was battery storage and community solar gardens, things like that?
Yeah, so it was a huge project. We had a suite of pilot programs working directly with real customers to test out new ideas and new technology. The suite of programs covered, like you said, a battery storage pilot where we installed batteries in customers' homes, and then we're able to control those batteries to operate the homes as kind of like little energy nodes on the grid. Um, while the customer then got to use the batteries for resiliency. And there's a community solar pilot that's ongoing, where customers from anywhere across the province can subscribe to solar energy from a solar garden in Amherst and get a credit on their bill for that solar energy that's produced. As you know, we worked on EV smart charging pilot, and had two sort of iterations on that, which were different approaches, but basically one approach where we installed chargers in homes, and could control the chargers to basically control how much power was delivered to the vehicle at any time, allowing us to move energy around effectively, or energy use, to different kinds of day. And then the other version of that was we actually could send a schedule to the vehicle directly, and the vehicle could then coordinate the best time to charge that vehicle. We also worked in the commercial space, so small commercial and industrial solar plus battery pilot, where we were investigating how best we can use larger distributed batteries and large-ish connected solar facilities. We worked on a pilot with Efficiency Nova Scotia to coordinate buildings, so building management systems, under the same premise, like, what is the best time in which those buildings can use energy, and is there times in which they can avoid using energy that then ultimately lowers the total cost of operating grid and pay those customers for that service, influencing HVAC systems and process systems, all while maintaining comfort in building and operations. And finally, we had a small investigation of what does bi-directional charging look like, where we installed two of the first bi-directional chargers in Atlantic Canada, certainly east of Toronto, Quebec area. And we specifically operated them in a vehicle to building manner, where we were trying to influence how the vehicle could deliver services back to the building by discharging the battery at times that were advantageous. So lots. It was huge undertaking. This is all underpinned by the energy system platform, and how that system can help coordinate all of these resources together in order to operate these distributed resources as a tool for the energy system and allow customers to participate in energy transformation.
What was the goal of Smart Grid? There were probably a couple of major goals that you set out to achieve.
Yeah, I mean, we were interested in investigating how operating in new ways, or delivering access to new technology could improve affordability, reliability, and environmental performance. And that's all summarized in basically what is the best way to integrate these distributed energy resources. We know that customers want some of this technology, or at least many customers are interested in this technology, and in some cases, like batteries in particular, the technology is still kind of out of reach in terms of affordability. But if we can share in the value of that new technology by sharing in what it is able to provide, like in the example of the batteries, using them to manage energy in the home while they're on grid, and then the customer using it to manage through an outage, say a storm situation or an unplanned outage, that we can actually lower the total cost to the customer, get that technology in their hands sooner, and then also get it on the grid sooner to actually provide benefit for everyone. So that was the goal, to investigate how best to do that. What are the underlying strategies, technologies, to do that? What is the performance of the program with the customers, but also the performance of the devices, and how they interact with the energy system?
Hmm. So as well as, gathering a lot of data and learning and studying people's, energy use, what were the key findings, from the Smart Grid project?
Yeah, so key findings show that in many cases, distributed energy resources can contribute to improving affordability, reliability, and environmental performance. Um, in some cases, certain devices perform one of those things better than others, for example. So you can maybe shift energy from a time of higher cost to lower cost with energy storage. The batteries, for example, do have the resiliency benefit. Like they perform very well for our customers when there was an outage, supporting customers through 99% of their client outages throughout the pilot. Um, Similar to moving energy from a period of higher cost to lower cost, um, that is also true of moving energy use from a period of potentially higher emissions to lower emissions, just all by timing when that energy use is happening. And one of the major sort of technical findings on that, if we step back from the programming the benefit lines for a second, is that it really depends on the time of day and how good you can become at optimizing for when you do send commands to different devices or when you do ask for the devices to do something for you. So we got a really good sense of like the hours of the day that certain devices are able to provide benefits and certain devices aren't. So that was really exciting. Like you said, we've got one of the largest, the largest data set of EV charging data in Nova Scotia of its kind, basically 2.5 years of hundreds of vehicles charging. So we understand how people use EVs, and that's going to be able to inform programming going forward. Investigation of bi-directional charging to understand how to match the vehicle availability with bi-directional charging. So yes, you can discharge the battery to a building, but you got to make sure that that vehicle can drive to where it needs to go, or that the opposite there is that it's actually going to be there for you to discharge when you need it to discharge, so that you can actually capture the benefit. So lots of exciting, very specific nuances for each technology that we'll be able to springboard off of into programming in the future.
The environment is changing, as we all know. And for example, we live here on the East Coast, and we're bound to have, we're at active hurricanes. We're coming into a strong season, and hurricanes and storms, they all have an impact on the reliability and the resistance of the grid. Will bi-directional charging be part of the future plan? And while you're at it, briefly explain, to people who don't quite know what bi-directional charging is.
Yeah, I mean, so bi-directional charging, I'll start there. Bi-directional charging is when a vehicle can not only receive electricity from the grid, but it can also return or discharge electricity back to the grid. Often this is going to happen through a building, through a home. And so uh, the term is starting to become this vehicle to everything. Originally, you might have heard vehicle to grid, and then now we're hearing vehicle to home, vehicle to building, vehicle to grid, vehicle to load, vehicle to everything. And so
Right.
that's why the bi-directional charging piece is just the return of energy back from the vehicle's battery. If you think about the opportunity here is that a vehicle stores a considerable amount of energy in its traction battery or the large battery that actually allows you to move the vehicle around. And range that you deem reasonable. And often the amount of energy that's stored in those batteries can be 5, 6, 7 times the amount of energy that's stored in some of the more popular home battery systems. So there's this huge opportunity at these big batteries on wheels that are bought and paid for the use of transportation. And so since the vehicle spends a lot of its like parts, whether at home or at work, the concept really is like, what if the vehicle could provide other services while it was parked? Often people think about it as, having your vehicle get paid while it's parked versus paying to park. No, it remains to be seen how that plays out in terms of what it's worth. But I can say that we're seeing a lot of car manufacturers, EV supply equipment, EV charging manufacturers put effort into making vehicles and chargers compatible for this type of operation, or at a minimum announcing very robust roadmaps that include bi-directional charging. In particular, in the consumer space, that's going to be led by resiliency. So I think the most popular or most mass market view of that was when the Ford Lightning launched Power Your Home for 3 days. They said Silverado is out there now, the Chevy EV truck, and it's also offering resiliency play with vehicles grid under this idea that those trucks in particular have some of the biggest batteries on the market, sort of 10 times the size of a typical home energy system, and so lots of opportunity there to offer a resiliency benefit to a customer, as well as easily maintain a reserve to do some travel or time to recharge after the outage event.
Now that the project is wrapping up and you have a lot of the data, what's next? Will there be more like this in the future?
Yeah, so the purpose of Smart Grid Nova Scotia was to investigate and de-risk some of these concepts before launching full-scale programming that was maybe less understood at the time that Smart Grid was started. And so now we can take learnings, whether they're technical or problematic in nature, and really use those to craft solid cases that are better understood to deliver programming for customers in order to operate the grid in a way that benefits everyone. I like to say that these types of programs or participatory program is a win-win-win. So it's a win for the utility that can lower costs. It's a win for the participating customer that gets the benefit of the technology or the affordability, resiliency, or environmental benefit. And realistically, it's a win for the non-participant as well, because if this truly pans out as a way to deliver the same or better benefit to the greater system, greater group of customers as a whole, then even if they're not participating, they're benefiting from that lower cost, lower emissions, and greater reliability. So we're excited about the promise of what we've learned to date and how we can apply that to building business cases around this technology that we know customers want. Customers are choosing EVs like never before, and that growth is still trending upwards. We know that customers have a high interest in solar and batteries, and we know that building owners are always looking for ways to lower their total costs. And we'll participate in a program that allows us to work with them to coordinate when they use energy. So lots more to come on all of these programs, I think, in the future.
Awesome. Well, sign me up. I'd love to be guinea pig for future ones if you're doing residential. Well, thanks, Ed, for joining me today. It was wonderful to have you on the podcast, and I'm excited to see what's ahead for Nova Scotia Power, and I know that you guys are working hard for the resiliency side and also prepping the grid for the future. So, thanks for joining me today.
Yeah, thanks for having me, Maria.
Well, there you have it. That was Ed Cullinan of Nova Scotia Power, who was talking about the Smart Grid project that is wrapping up with all kinds of information that they've gathered over the period of time on battery storage, community solar gardens, EV smart charging, and bi-directional charging. Thanks again, Ed, for joining me. And by the way, if you have any questions about today's podcast, make sure you go to our website and fill out our contact form. It's reimaginedenergy.com. And just letting you know as well, this podcast is sponsored by Smart Energy. It's a conference that's held in Halifax and in Vancouver, and it brings together a lot of smart people in the energy field. Make sure you register or follow them on social. I'm your host, Maria McGowan. Thanks so much for listening or watching today, and we'll hope to see you next time.